Okay, good morning, everybody. So I'm going to start wherever we stopped last time. Let me. Good morning, Mesh. Wednesday, as I sent, we will have a article in regards to the ideal feedback amplifier. بدون الفولتج amplifier قبل ما نحكي عن هيدي الشيت. Example similar to the ideal case where beta is directly known and alpha is directly known, and we know the relation between Ri و Ro, RIF و ROF. يعني Ri و RIF و Ro و ROF. So today we will continue with the ideal voltage case. Okay, last time we explained that if we have a structure with a basic A block and a basic beta block, we will devise a rule sheet that will explain how we will find the modified circuit. And we said that there are 3 steps to find the full feedback amplifier characteristics. The first step in blue is to derive R11 and R22 from the beta block. And then the second step is to modify the A block, find its gain, Ri and Ro, and then use the information from the A and from the modified A block and the beta block to derive the quantities, which are the third step of the full feedback amplifier. So we'll take an example now. And this example is the same amplifier that we saw before. But the difference is now the amplifier is not ideal. I have RID inside the amplifier. What's different is that this current here going up or down different from 0. And so the placement of this amplifier of a beta block, which is the blue block, which is taking feedback from the output and going back to the negative pin of the amplifier, صار حيمرق لي current. It is going to affect the original A block. It's going to load it, and it's going to affect the current that is flowing in the A block. It's non-ideal. Because it is non-ideal, what we have to do is we have to separate the effects. We need to model what is the load of the beta block of the A block, and we need to figure out what to place this to build a modified A block. In this picture, he is showing me in blue the beta block, and he is also showing me that for the full feedback amplifier as a full feedback amplifier voltage out مثل ما حكينا is seen بعد ال RL, but OF includes RL, and that my RN is seen after RS مثل أي amplifier, but IF is RS. Okay. So this is step number 1. Identify the beta block, which is here highlighted in blue. And we start to find the characteristics of this beta block. So for the beta block, we can see that the side from the, let's go back to the previous slide, the side coming from the output, it as port number 2, and the side that is sending the feedback, we label it as port number 1. نرسم البتا block home port 2 home port 1 وحنلحق الرول sheet which I summarized or I put for you here This is how we derive R11, R22 and the beta gain. R11 هيدا series يعني هيدا parallel هيدا السايد وهيدا series and R11 is looking into port number 1 is we shunt port نعمل له shorting so that is really shorted circuit. Okay. Now this and shorting the port number 2 if I am looking from this side here on port number 1 and I'm shorting port number 2 and I'm asking what is the resistance seen with this arrow. It is R1 parallel to R2 so R11 is really R1 parallel to R2. عندي سؤال هنلحق now R22 R22 what we need to do is we need to again bring the beta block but we have to look from side number 2 and because this is a series parallel this side يلي أنا I'm not looking from remains open so this is an open circuit so practically speaking I am looking from this side I keep this as an open circuit and the resistance that I see here is R22 it is really equal to R2 plus R1 هيدي كلها loop so this is R1 plus R2 now what the value of R22 is then we have to find the value of the gain of the beta block what is beta equal to شو يساوي الجين للبتا block the gain for the beta block I place a voltage source at side number 2 and I keep side number 1 open circuit يعني ما في current flowing فيها and I find the ratio of VF بيعطيني الفاليو لل so I'm practically putting a voltage source here مع VO what is the value of VF versus Now note that the positive pin is the upper pin يلي عم يبعت الفيدباك amplifier. It's simple in this case. This is a simple voltage divider circuit and the ratio for beta is R1 R1 plus R2. So think about the beta block بس على البتا اللي لها خلصوا R11 ولا R22 منها بكبهم بالموديفايد A بشتغل بالموديفايد A يعني بس نسحب منها قديش هي it affects A with its own beta isolated كان سؤال عن البتا بلوك processing
اليونتس تبعها مش دايما
بس amplify the volume لأنه I minimize my volume مش عم اسمعكم منيح yes go ahead
مش دايما اليونتس تبعها volts per volts
in other amplifiers it is the opposite of A يعني transconductance إذا هو volts على amps بتكون هي amps على volts its unit is the feedback quantity على output quantity يعني الانبوت على الاوتبوت بحالة الفولتج امبليفاير عم تكون فولت بير فولت عندي سؤال تاني summary this is the sheet that you will see in your slides actually this sheet is not exactly in your slides I built it I can send it for you but this is how we process all the quantities for the beta block خلصنا من البتا بلوك السكشن تاعون الموديفايد A circuit تاعون الموديفايد A circuit بيقول لي if you know what your A block is and plug in R22 parallel L so R11 محل ما الفيدباك كان جاي بالفيدباك amplifier series with RS and block إذا نطلع فيها our A block is really whatever is highlighted in here لأن هي الأب أمب يعني محل ما عم يجي ال VN ويطلع في out هو البيتا بلوك والفول فيدباك امبليفاير هو الكومبينيشن لأنهم اثنيناتهم مع RL مع RS. So what we need to do first is to remove الفيدباك بيتا بلوك نشيلها كلها حنقيم هيدا الكونكشن هون. What we are going to do is we are going to plug first R22 parallel ل RL across V out اسمه R22 حيقعد على ال V out parallel ل RL على البن كان جاي عليه الباك فولتج هو كان جاي على هيدا البن نرسم R11 على الجراوند فمثلا R22 قعدت parallel لل RL و R11 قعدت in series مع ال RS وال RN loop هيهم قعدوا in series it will fill the gap of wherever my V feedback should have appeared. يعني عملت لي loading محل ال VF للبلوك. احنا كليا عم ننسى البلو بلوك اللي تحت صار عندي السيركت هو أكبر. Look at the whole thing and let me best to keep the same discussion. Let's really forget about the beta block لأنه نحن عزلناها. And if we look now at the orange block, it's really the orange block يلي هي فوق. يعني أنا أخذت البيسك amplifier وحطيت resistor R22 parallel ل RL وحطيت resistor R11 عفوا محل ما الفيدباك كان لازم يكون وحطيت ال RS وحطيت ال RL هيدي كلها الموديفايد أي بلوك محل الفيدباك عزلت البتا وحطيت parallel resistance على الأوتبوت وقلت this is my modified A block now. انسوا البلو لاينز تاعون RIF و RN و ROF و ROut. Let's forget about them for a moment now. سؤال وين حطينا ال R22 أو وين حطينا ال R11. Is it clear what is the modified A block now? Now I have a modified A block اللي هي الامبليفاير نزاد عليه R22 R11. نحن نقدر ندرس لهيدا البيج امبليفاير ندرس first الموديفايد A circuit. خلينا نطلع على الموديفايد A circuit. I simplified this modified A circuit for me. So you are really seeing a loop of RS, RID and R11. R11 هون بس حطلي الفاليو اللي لها وهي R22 حاطة parallel لل This is how your amplifier looks like. يعني بس شايل هيدا التراينجل اللي كان engulfing هيدول عليه إنه هو عم يخلق عنده لوب هون بين VN RID R11 وعم يخلق عنده هون gain across voltage divider where R22 is parallel to R. So let's take quantities من هيدا المodified A. gain A RI RI includes RS و includes RL هلا part من المodified A circuit. gain A هو VO على هو input هو VN أو حل ال VS إذا نرجع على هاي الرسمة بس حتى نكون consistent. I don't call it VS anymore, I call it VN and this is my VO. على أساسها لما بطلع عليه بقى بسميه RI تاعون الموديفايد amplifier وبسميه RO تاعون الموديفايد A circuit. إذن لما ال RL وال RS VN هو على الفرونت عم شوف له RI including the old RS الجاي من الامبليفاير و including the old RL الجاي من الامبليفاير. هيدي بس بدكم تنتبهوا. هنا لهون if we come here now we find what are the quantities. A أول شي بدي طلع V1 voltage division هي RID RS plus RID plus R11 يعني quantity اللي هون V1 VN VN and this quantity here is VO over VO. So V1 على VN تجي voltage divider من هاي البلوك and VO على V1 تجي as another voltage divider because we know that VO هي هيدي RL parallel ل R2 RL parallel ل R2 plus RO times mu V1. So another voltage division تبقى الميو هون لما باخد VO على V1 تطلع the second quantity for the طبعا modified A so this is really the modified A. هيدا السيركت طلع له I وطلع له ال RO. Okay. So to find my RI and RO, to find the input resistance, what I have to do is I have to look from VI. It's simple. I have a loop of 3 resistors in series. So it's equal to RID plus RS plus R1 parallel R2. The next step is I need to find for my circuit what RO is. So what I do is I set the input to be 0 يعني هيدي راحت صارت grounded هي النود هي already ground عملنا shorting معها ميو V1 بما إنه اللوب كلها فيها 0 voltage so that is also 0 so that is shorted and I'm looking from here I see 3 resistors in parallel which are R2 parallel RL parallel R. So ثلاثة quantities in parallel. صار عندي الموديفايد أي ال RI وحدا عنده سؤال؟ Frederick. So now that I have those 3 quantities, I have my A, I have my beta, I have my RI, I have my RO. ال R11 وال R22 بنساهم خلص طلعوا بال A quantities. RO. I can now plug and play, just use the equations تاعون الريل case of the full feedback voltage amplifier. هيدي الايكويشن بقت معنا من الايديال كيس هي في او على في اس هي على 1 plus beta A but this is the modified quantity F RI A so this from here OF and ال RO تاعت ال A. Now, if you still wants to know what Rn is, what Rout is of the full feedback amplifier, I have to remove Rs and Rl from them. نرجع regular concepts that I learned. I know that in the case of the full feedback amplifier, Rn is in series with Rs. RIF RIF minus Rs I get Rn. same if I look here بما انه اثنيناتهم hinging على الفي او نود بعرف انه ار او اف هو البارلل له ار اوت for R out وهي هالايكويشن in terms of R او اف. بعد ما نطلع ال RIF وال ROF وال RO we subtract RS we get RN we subtract 1 R out أقل من 1 على ROF we get 1 على R out. Okay, in parallel. And there's a question about this slide.
مس
Yes.
بس نحن ال RN مش قبل شوي طلعناها أو نحن طلعنا RI.
هي الفول فيدباك هو كلهم quantities full feedback amplifier.
أوكي.
الثلاثة لأنه هون بغير لون modified A. Okay, including RS و RL.
أوكي.
لما نرجع على الفول فيدباك يعني عندنا third step information. شفتوا كيف راسم لكل السيركت هون RN وين بعد البن تاعون ال VN.
إيه صح.
This is what you need to now think. مثل ما كنا نفكر قبل إنه بعد ال RS بشوف ال RN full feedback.
أوكي يعني أنا بدي أول شيء أعمل modified A طلع ال values لأستعملهم بالفول feedback وطلع ال values التانيين.
هيدا البيربل اللي استعملته هون ال A هي اجت هون هي اجا هون واجا هون. implicitly طلعنا RN و R out equation that follow.
أوكي.
You're welcome. Okay, anybody has other questions? Okay. The slides that come after this numerical values. So you to practice them. I'm going to walk you again through them بس for the sake of the steps. The given mu the amplifier شو بتساوي RID اللي هي هون أعطانا إياها وبالتالي what is RL الفيدباك بلوك أعطانا إياها وأعطانا RS للسورس. So it gave me all the quantities. Just plugged in the 4 quantities on the previous slide. طلع دغري A وبتا و RI و RO من السلايد اللي قبل. فهنا resistance شو بيساوي؟ on this side حطلي ال equations full feedback amplifier يعني we labeled in red in the previous slide. تطلع ال AF وال RIF وال ROF and then you can find RN and R out. And he gave me the answers here. Just for example, look how RIF is 77 10K صلح ال 10K منها طلع RN 767 بينما كانت ال RL وال R out he says that ROF he finds it to be 95 ohms RL is 2K so بيقول 1 على 2K 1 على 1 على R out equal بالحالة 5 ohm بنعملها 0.095 وكل ال R out what is its value. أو بعمل equation دغري مثل ما شايفينها بس انتبهوا للunits and then find the quantities. So it's just a numerical application. طلع كالني على هيدا السيركت وحنجزئه لكذا if I have it blacked out. Okay. So I'm going to draw it again best for you to follow what the circuit is. And I'm going to draw it in purple. I will hopefully try to not get scratches. أول شيء ground transistor جاي عندي السيجنال هيدا الانبوت طبعا VDD and we know what it is. transistor عفوا هيدا أول transistor and then I will tell you what happening. I have a second transistor and second transistor طلع منه كمان the output. Okay, let us draw its resistor. Get the output from it and this is also ground. هدول الاثنين إذا طلعنا عليهم هيك إذا هيدا VN وهيدا VO two common source amplifiers. وكنا نحكي what is the gain now if it is positive or negative the gain for the A block. ال A block فينا ندرسها ما ضروري ندرس ال modified A block لما بدنا نعرف إذا stage is really positive أو negative الgain تاعنا. شفتوا كيف بلش لأنه أنا معي two common source stages from the gate to the drain. source لو كان عنده resistance amplifier هي minus GMRL parallel ل RO source resistance بقسمها على 1 plus GMRS. gain من V1 ل V output is negative. common source الثاني من هون لهون كمان الجين negative. يعني عندي gate to drain negative مطلوب بأنظر شو؟ هقول لك شو هي ال R1 R2 بس هلا أنا عم أقول لك إذا أنا عندي two common source amplifiers see what are they and what is their gain in the of the block. إذا عم بدرس من gate لدرين عندي negative هون gate لدرين كمان عندي negative. So بتطلع block إذا أنا اعتبرتها two common source amplifiers is positive. هلا purely two common source amplifiers. Let's now look at what I see here. From the output أصلي resistor R2 ويعطيني some form of non-ideal voltage division voltage across resistor R1. بدي على طول اعتبر نحن لقلنا for our course the beta block is simple. حكون عم بخلق أنا some form of the voltage division from sensing the output back into the input and subtract from the input. طلع هون لما كانت السيجنال بس across the gate voltage خليني أشيل بس هاي لما كان الانبوت signal across the gate voltage what my VGS هو الكرنت اللي عم يقطع بهالريزستور هو M VGS صح؟ لي voltage proportional ل VGS. This was all of VN. هذا ال VG وهي ال S. Okay. Now when I put the feedback, when I put a resistor loop, okay. أخذت من هون output منه current current built a voltage in this resistor هيدا هون شي كأني عم بعمل some form of non-ideal VF فعليا عم بصير in series مع input value بيساوي VF يعني عندي VGS لهالسيركت بسج أو VN أو F. أوكي أنا خلقت ال subtraction by putting this loop here. هذا اللي بنشوفه هون هو كل السيركت، يعني هذا هو كل الفول فيدباك امبليفاير. منه الموديفايد اي بلوك، هلا بعد شوي بنرجع بنخلق الموديفايد اي بلوك. بس هنا I can clearly see the beta block is really the same block that we saw in the previous circuit, where this is 2 and this is 1 and this is ground. اوكي، البتا بلوك تاعيتي، وبعرف منها انه اذا بطلع بتا حتطلع هي R1. اوكي، عملناها قبل بالسلايدات اللي قبل، انا نفس السيركت هي فولتج ديفيجن بيور، البتا لحالها بوزيتيف. الشغلة اللي بقدر أكد له إياها، أي بتا البرودكت تاعونه بوزيتيف لأنه اثنيناتهم بوزيتيف، سو أنا عندي نيجاتيف فيدباك. وبعرف شو هي البتا بلوك، وبعرف من الإكزامبل اللي قبل طلع منها ال R11 وال R22 والبتا، صرت بقدر أعرف أخلق الموديفايد أي بلوك. أوكي، عندي سؤال so far. What we are going to do is we are going now to raise the feedback block. Okay. شيل البتا بلوك من السيركت، وكل ما كانت عم تعطي فيدباك تيكون ان سيريز مع الانبوت. يكون هون يصير هين عليكم تشوفوا الموديفيكيشن. اوكي، لا نزيدهم هيدا. اوكي، سو ارجع ارسم بالبيربل الاولد اي بلوك لحد هون، وهيدا الانبوت جاي عليها الفي سيج، حنسميه في ان هلا. وبرسم شغلتين محل البتا بلوك، parallel للاوتبوت parallel للفي او، يعني بين نود في او وجراوند. لو كان عندي ار ال كان حيكون هون R22 جاي من البتا بلوك. ومحل ما كنت عم وصل الفيدباك، محل ما كنت عم حط الفي اف بيوصل بينه وبين هالنود ان سيريز. اوكي، مع الانبوت، هيها ان سيريز مع الانبوت ححط R1. اوكي، it's clear for everybody how we put R22 and R11. It is clear. طيب هيدي هلا البلوك اللي صارت عندي هلا اسمها الموديفايد A. Now this modified A لو كان في RS و RL I would have included them. لا بدي طلع منها two quantities, three quantities. And those three quantities هن I including RS، بطلع منها RO، بطلع منها الموديفايد gain VO على house three quantities. I third stage substituting the values, and I calculate the gain of the amplifier. هالحالة R is infinite. Oh, when I set V into 0 أنا عندي common source وموصولين الجيتس. إذا كان 0 ال VO هون حيكون 0 لأنه الاوتبوت الانبوت تاع هيدا كمان حيكون 0، سو حصير حشوف هو R22 parallel لهيدا ال RD2 RO تاعون هيدا الترانزستور working up and down. معزولين، ما عندي current على الجيت، ما عندي connection بين stages. Okay, I can calculate RO and then I plug in the third stage where I find ROF. F اللي هي A على 1 plus A بيتا. فإذا ما حدا عنده أسئلة من هون هي سلايد عملتها بس لإلكم إنه البيتا بلوك، بس عم فرجيكم السلايد اللي معكم إياها شو فيها quantities. أنا من هون إنه هي البيتا بلوك two ports 2 and 1 and how we find the beta gain. And the slide that you have also will show you where we put R11 and R22. And it's telling you that if is very large because it is two common source amplifiers. شفنا بالأول إنه AF بتكون هي A على 1 plus A بيتا. إذا هي كتير كبيرة ال AF gain بيطلع بيساوي 1 على بيتا تقريبا. So you can immediately figure out what its value is. Okay. So this concludes the slides on part 6, which is the full feedback amplifier analysis. Okay. لحد هلا ما فيها frequency response. It's part which is part number 7, we shrunk it and we will study in it frequency response and the stabilization. قبل ما نقول part 7, does anybody have any questions on this part? So we will now move to part number 7. We have posted the new part for you on Moodle. It's 16 slides. If not, I will email it to you. And this part is going to talk about the stability of the feedback amplifier. What we said before is that we know that AF is equal to A على 1 plus A beta. For now, for this course, we will assume that beta is a constant, a simple network that doesn't have capacitance. It's comprised maybe only from resistance, or we will ignore its capacitor values, but maybe only from resistors. And this block, here the A blocks اللي شفناهم مثل common source اللي شفناه capacitors, so feedback resistance عندها transfer function A of S. Okay. This we're going to focus on the denominator, characteristic equation. لأن لو أي بيتا constant مثلا هني 1 plus 2 times 3, I know that my denominator will always be different from 0. F of S can vary. The gain can be, the magnitude of the gain, it can go from high to low. It can have a gain maybe equal to 0 dB, A مثلا. And it can have a certain phase, and the phase can change. And so it's very possible, this is a magnitude and a phase, to be positive or negative. It's very possible for the quantity A beta تكون تساوي -1 at some frequency, oh my god, okay, magnitude and phase, مش على طول, it changes. But if at some operating frequency omega I become A beta equals to -1, this means that the denominator of the characteristic equation might hit 0. And if it hits 0, this means that my gain will become infinite. And if my gain becomes infinite, my circuit is not stable. Now, if this omega happens to be among the frequency of operation which I'm interested in the range which I'm interested in for my design, I have to be careful to redesign my amplifier so that I have enough margin not to fall into this issue. Okay. and sometimes part of my signal will be distributed across different frequencies. نعرف definition اللي هو اللوب gain اللي هو A ضرب بeta. And loop gain, it has a magnitude and a phase. And what we want is that when the phase of this loop gain is equal to 180, يعني هيكون عنده coefficient -1, that the magnitude of L يكون magnitude لل A beta يكون أقل من 1 يكون stable. قلنا كتير أن يكون الماجنتيود أقل من 1 لحتى يكون عندي stability، بس الانفينيت بخلق الانستابيليتي، ولحتى أنا guarantee إن 1 - 0.1 is a finite number and I am operating properly. So أهم شيء الكونديشن أنا لما أوصل على phase بيساوي 180 degrees الماجنتيود تاعون أي بتا يكون أقل من 1. What we focus on in all of the lecture slides to come. Okay. هل عرفنا شو الأوبجيكتيف تاعنا؟ I want stability. I have a loop gain اسمه A beta. Let us on this slide introduce the definitions. Okay. The definitions are as follows. I can plot the product of A beta at a magnitude and a phase. I calculated it. I know that at some frequency, omega-1, the unity gain frequency with the magnitude of A beta equals to 1. If only 1 in volts per volts, dB, it is going to be equal to 0. When the A beta graph magnitude crosses 0, if I know the corresponding phase it's omega-1, let us say in this case it is مثلا 130 degrees minus 130 degrees. If I gave you those two graphs and you are able to read those quantities, then I will define something called the phase margin. And the phase margin is really how far is the phase at omega-1 from reaching the 180 degrees. Okay. So my phase margin is really 180 minus 130, and in this case it is equal to 50 degrees. Okay. So let me come back. Okay. Now, let us see. So for stability, he is defining now conditions. He is defining omega 180. Because أنا بعرف على أي frequency أنا بوصل لل -180 degrees. In this case, I call it omega 180. And it has to happen after omega 1. If omega 180 أكبر من الunity gain frequency, I have stability. I want to guarantee that I have stability with good margins. So أول margin عرف لي هو الphase margin، وبطلب إنه يكون الphase margin around 60 degrees to be on the safe side based on the experience of the designers. And so he defines something which is the gain margin. يعني هو الgain equal to omega 180 plus الgain at the unity gain frequency is typically 0 dB. Okay. So if omega 180 is below 0 dB by 30, the gain margin هيكون 30 dB or more, then fine. يعني إذا بجي بتطلع على الجراف بشوف ال 180 degrees when I see it's omega 180 and I see the corresponding gain, it has to be 30 dBs or more than the 0 dB line for the A beta إنه هالشي عم نحكي عنه هو A بيتا. بعد شوي حنعمل سلايد modification لهيدا الترم. حدا عنده question so far على definitions؟ طيب هلا now next slide. An example, and he tells me, let me assume that A of S has 3 poles, okay, 10 to the 5 with 10 to the 6 with 10 to the 7. And he says, I'm going to start to make you familiar to this term. I'm not going to give you beta. We know that beta is this quantity, it's a very small constant. I'm going to tell you that 20 log 1 over beta هي 85 dB. Okay. So I'm trying to give you a complex thing, but this will simplify your life next. Let's see why he's giving me 20 log 1 over beta. For the reason that I'm interested in studying 20 log A beta. I'm interested in studying 20 log A beta. So this quantity is equal to 20 log A plus 20 log magnitude of beta. And we can reinterpret it as 20 log A minus 20 log 1 over beta. And all 20 log A minus 20 log 1 over beta, why are we complicating things? Because I'm interested in the frequency of the intersection when this quantity is equal to 0 dB. And بدي اطلع 20 log A beta equals 0 dB. And this happens really when 20 log A is equal to 20 over beta. Okay. But in mathematics, if I want to say it's 20 log A, أنا عم برسمها حتى ما يعطينا هيدا شحاويط. 20 log A was equal if I also draw on the same graph 20 log 1 over beta. إذا رسمته هون the intersection of whatever they are equal. Okay. هذه النقطة تعطيني 1 أو اليونتي جين فريكونسي اللي كنا نسميها أوميجا تي. هيدي الانترسكشن بدل ما ارسم drawing 20 log A بتا وارسم الزيرو دي بي لاين وارسم من بعضهم، انه حنرسم 20 log A ونرسم 20 log 1 over beta. The intersection represents what would have been the 0 dB line in 20 log A beta. Clear? السؤال؟ Okay. So let's finish this slide. What it's telling us now, it's telling us first اللي هو نحن بنعرف نعملها من البود بلوتس من قبل. Okay. 20 log 1 over beta on the same plot. Okay. What we're going to cover next time عنده 3 poles في الفيز تاعونه بالنسبة لل3 poles احنا كمان numerically لنهون علينا ما نعلق بالفيز plot how to calculate phases. الانجل لل A هي عبارة contribution للنيوميريتور هو انه positive minus arctangent f على 10 to the 5 لانه هون عاطيني اياها 2 باي منها هو minus arctangent f على 10 to the 6 minus arctangent f على 10 to the 7. اوكي ترى حيلا frequency طلع الفيز من هيدي الايكويشن. It's going to draw it for me and I know how to draw the magnitude of it. Okay. only ل 20 log A magnitude plot و only ل 20 log A sorry عفوا لل A الphase plot, and it's going to draw the line of 20 log 1 over beta, and next time we will comment how we draw it just as a refresher نضيف منها الشرح. Okay. حدا عنده سؤال؟ Okay. Thank you very much then everybody, have a good day, and we will talk hopefully next time. Yeah. I'm not seeing if you have questions, sorry. Okay. Yeah. Thank you, bye.